Welcome everybody to Dallas Programmable Robots Group's Robot Builders Night Virtual for January 6th, 2026, first meeting of the year. Tonight we will do our normal roundtable presentation with anybody that's got something to show or ask a question, and then after that we'll open it up to open mic. So to start off, a little bit of housekeeping. DPRG will hold its annual members meeting on January 24th at the Dallas Makerspace. Agenda is going to be elections of officers for 2026. Brainstorming session on what members want the club to do in 2026. Any tech talk topics or anything else. It's open for discussion. And then a show and tell for any robots attendees may have brought in. Sometimes members bring in stuff to give away or trade or that sort of stuff as well. A list of candidates has been emailed out to the DPRG list server. You guys may have seen that. I believe it was posted on Discord as well. So that's what we have to look forward to. To start things off, we have Stefan, new member, and he's going to show us his robot that he's working on.
Hey everybody, so this is my robot. I call it R5D2, and I came up with that name because it's roughly 5 times the size of a standard robo-bag, and it's got 2 driven wheels, so it's differential-drive. And I'll give it a little spin and hope it doesn't fall off the table. So there's the control interface. It's got an ESC32. And that's running the web server, and that's how I control the robot over the phone. Yep. So it's my robot. Thank you.
Well, that's actually...
So the lights in the front, are they lights or are they something different? Are they just toy lights or?
Oh yeah, so they're a 12-volt LED landscaping light.
Whoa.
Actually, they with the wrong one. They're way too bright. So,
Oh.
Is your phone app an Android? Did you program it yourself, or is that a canned program?
yeah, so that's actually just a Chrome web browser, and I go to 192.168.4.1, which is the CAS web server that's running on the ESC32. So there's no Android app at all. I could do this from my Ubuntu computer too.
That's neat.
Thank you.
Is that what did you use for the frame? Is that plywood?
Yeah, it's 3/4 inch plywood. I added.
I like that. A fellow plywood enthusiast. I have a couple robots made out of plywood.
Yeah, you know, it's great because you can drill a bunch of holes in it and you realize, well, that isn't going to work out. You move over 2 inches, you just drill more holes.
Yeah, it's way different than 3D printing something. It's easier to recover from a mistake with it.
So there is one place where 3D printing would be super convenient.
Oh.
And these toy gearboxes, I don't know if you can see that.
Yep.
But getting a gearbox made out to the steel hub, like I had to make the ugliest piece of plywood you can ever imagine with like 6 different drill bits. And if I could have had a 3D printer, just maybe scan this and scan this, that would have been cool. Maybe next time.
What's the battery in this?
I have a 12-volt, 7-amp SLA battery, and I'm getting about 2 miles of runtime.
Wow.
That's not
And
bad.
so everything is done on the ESP32.
Yep. The ESP32 is I'm kind of maxing it out as far as what it can do running the server, but it can handle it. The relay, I think sometimes it causes it to brown out, so I might run the relay on another ESP32 and just have two ESP32s next to each other.
That's interesting. You have encoder feedbacks on the motor?
No, so we were talking about that a little bit earlier. These ride-on toy motor gearboxes don't have any encoders, and they only have a little bit of shaft that's sticking out. So I'm thinking I might epoxy a magnet or something on there. But yeah, having encoders would be awesome.
What I did, Stefan, was I replaced the 550 motors that were in them with ones that had encoders. You can get them on, I got mine at AliExpress. So that's the easy way to do it. I'm still messing around with those. I haven't, in tests, they work. You know what I mean? I get good encoder counts, and I also, the motors, there's enough power to turn the wheels at a reasonable speed and everything. I've seen both 12 and 24 volt motors. I got 12 volts, and in hindsight, since I'm thinking of using a tool battery, which is 18 volts, I probably should have gotten the 24 volt ones, but I'll make it work, whatever. But yeah, I have an outdoor rover I've been playing with that uses two of those power wheel things. They're very, you get an awful lot for, you get an awful lot of power for not too much money.
Yeah, can I ask, I'm using the BTS 7960 motor drivers to drive them. What are you using that for me?
I have a little, I don't have it at my desk right now, but I can look it up and put it in the chat. There's a little motor driver that I want to say get up to about 10 amps per channel, which I think should do these pretty well. Like I say, I'm still messing with them. I use, when I was messing with them on my bench, I was using power supplies, and that's why I think they're pretty efficient. So let me I'll go look that up and see if I can find that for you.
So Stephen, I might have missed it, but are you doing this just for fun, or you have something you want to do with it?
So this is just for fun right now, but potentially kind of what I'm doing with this is I'd like to have a lawnmower edger and kind of vacuum combo to the yards.
Oh.
3.125. Anyway, there's an example of the Polulu ones. I think if you just look up item 3499, these are the magnets here. They're about, like I said, I don't know, maybe 2 centimeters across, and these are the piece with the Hall effect sensors in them, and they're quadrature, so you can get rotation direction out of it. So,
Okay,
and they're pretty cheap.
and you will put that on the shelves. So yeah, that'd be awesome.
Say that. Oh. I'm sure there's probably others too, but I've used those quite a bit and they work pretty good.
I take that back. They were dual 5 amps.
Dual 5 amps. Okay.
Yeah. I'll put this link in. I think it.
3.078.
See how you. I'll go there. Oh yeah, but they're inexpensive. That's good. So if you blow them out, you get 2 for $10.
You buy the 4-pack?
And if I remember right, they do a pretty good job of. But these are only go up to 14 volts. So if I go to the 18-volt motor, I'll probably have to switch. But this is the ones that I initially had started to play with. Let's see. Let me put it in chat.
Yeah, that's fine. So Stephen, what kind of power management do you have? Like, how do you handle the back EMF from the motors, so it doesn't blow up your electronics and stuff?
You know, I think the BTS 7960s have a diode in there, and I think it takes care of the back EMF, but that just hasn't been a problem for me.
Mhm. Okay.
I have approximately like 10 miles on this, and so far, you know, I had a problem the first 7 miles, and then I just hot glued everything.
How do you turn the power on and off? Is it a switch?
I got a switch back here.
Yeah. Mhm.
So this turns all the power on and off, and inside here I have a buck converter that sets the 12 volt down to 5 volt for the ESP32.
How about the motor? Is the motor connected directly to the battery, or through the, like, is the motor controller H bridge connected directly to the battery? And how is it powered on and off?
Yeah, so the battery is connected to a switch, and then that's connected to the H bridge. So I can, so like, if the robot like does run away, I can physically switch it off. Yeah.
Yeah, because one thing is, like if the motors are turning and you turn the switch off, that's when you'll have a big EMF pulse or something going on. It'll just, the energy has to go somewhere, and it usually goes to the battery. And if it's not connected to the battery, that energy has to go somewhere. So watch out for that. Yeah.
Okay. Yeah, the ESP32 is not expensive, so you know if I roll it out, it's not like a Raspberry Pi where I do it's bad.
Yeah.
Yeah, usually just putting a diode in the right direction across your power switch, it provides a path for that, inductive energy or kick to go somewhere.
Yeah,
back to the battery.
Like normally, if it's in rest and you turn the power switch off, it's okay. But if it's somehow in motion and emergency stop, that's when you can get in trouble.
Okay.
That's good, Stephen.
Thank you.
Is it Stefan?
Thank you.
What?
Is it Stephen or Stefan?
Oh, sorry, it's Steven.
Stephen. Okay. Thank you very much. That's excellent. I made a note. I put up a gold star for you for doing the presentation with the movement.
Okay, thank you.
Next up, we have Jim.
Okay. Would you like me to share my screen where I can put up some more details?
Yeah.
Okay.
So I can pin your screen here. You want to show your
There we go.
robot?
So this is
Cool.
I don't know how many of you remember the Parallax Stingray that is now out of production. Well, this is the Parallax Stingray reproduced in acrylic, with the same pattern. This is the original wheels, original caster with an Omni wheel, but the rest is all done in top and bottom are 1/4 inch, and the side panels 3/8 inch acrylic. And if I can share my screen, I'll take you to my I want that one. This is my GitHub, which I can put in the chat. If I can find the chat
Mm-hmm.
somewhere. Need to move this out of the way. There's the chat.
Oh, but your
So
camera's really, your
that's
camera's
my
really low. Yeah.
GitHub address. Say what? The camera?
Yeah.
Oh, this
Your-
is the same picture. Yeah, this
your
is an OP.
Yeah.
The LiDAR's on top, of course, to give you the most angle. I had an AI create a logo for me. This is Stormy the Stingray. This is the original Parallax Stingray, no longer out of production. I did actually a Robot Magazine article on it when it first came out, and that's how I got it as a free sample. I called the Bobot's big boy bad brother. This is where I laser cut a copy of the original panels, and of course here's the rogues gallery, and then I've got a listing of the hardware. Replaced the motors. The wheels are no longer available, but I found a similar source. You know, the wheel specifications for your URDF and all that stuff. Handling the power using the 52 pi power hat, because the Raspberry Pi 5 is pretty demanding, and it requires a minimum of 5 amps at 5 volts, and many power supplies just really can't handle that. But if you put that, it has a plug here, so I put my battery into here. I use a LiPo 14 volt battery, and it takes it down to a very nice 5 volts and feeds it in through the USB-C port. But it also has a 5 volt takeoff, and from here I can also power the OAK-D and pretty much whatever else I want. I have some external memory which goes on a Raspberry Pi hat. So it shows it on top, but it's actually underneath now because the power hat is on top. These are my batteries. I got a LiPo screamer so that if the battery gets below a certain point, it'll warn me very obnoxiously. Of course, the safety bop to stop button. I have some from scrap power bus, so that the battery power goes into here, and then I take off to go to the Pi hat. But also I can take off full battery power to headlights and that sort of stuff. And because of the EMF thing that we just talked about, right in between here, I have this Phelan shunt regulator that'll handle the back kick EMF. Then all that power goes to a Roboclaw, a 2x7 amp that runs the 2 motors. I've got a remote kill switch that goes to an e-stop on the Roboclaw so that I can have it shut off the motors. I've got some headlights, made some slide switches to control the headlights. And also, sometimes the Roboclaw will act up funny and it'll go into an error state and it won't clear until you turn off the power and back on again. So I'm going to put a switch on that so I can reset the Pi. I had a YD LiDAR, was belt driven, and that belt is several years old and it's getting frayed, and it's almost impossible to get replacements. You certainly can't get it from the manufacturer. They just won't bother for such a trivial thing. I did get some from, I think, AliExpress, and they sort of work, but don't ever get a belt-driven LiDAR. Get one that's direct drive, and this one works really nicely. It's LD19. And I had a choice of cameras. To start off with just a Spinel fisheye camera, but I'm now using the OAK-D so I can eventually take advantage of the point cloud. It also has a built-in IMU, which I tried to use, although I'm not sure how I'm setting it up wrong, but its axis is very cattywampus compared to the axis of the robot, so I got to figure that out. And there's also the RealSense, although I understand it's a little harder to use, particularly with ROS, although people have done it. I'm using Ubuntu 24.04, Fuzzy Jalisco, Gazebo Harmonic, Nav2, and I've got a couple of Floorbot challenges that it succeeded, where I was able to tell it to go to the other end of the house and back again successfully. So that's it. That's my show and tell.
Very nice. Very nice.
Questions from the peanut gallery.
You know, one thing that I don't know if it's common knowledge, but if you're using a Raspberry Pi 5, it actually negotiates with PD protocol. And so if you just try to slap a 5-volt power supply on it that doesn't negotiate, you're always going to get you don't have enough power warning, which means the biggest effect would be that it limits you from fully using the full power capabilities of the USB ports. And that's probably the thing that most people would key on first. So like you might find that your Oak D light doesn't work real well because you can't get enough power to it because, now if your power is separate.
Well, that's the whole point of the Geek Pi PD power expansion board. It does negotiate the PD protocol. Yeah. You could also if you know that your power supply can supply enough, but it doesn't do the handshaking, you can do a couple of like 3 settings on the Pi where you can tell it like, don't worry about this, I've got you covered, and it'll stop complaining. But then it's up to you.
I didn't know that. Will it actually power up your USB ports?
Oh yeah.
Okay.
I'm running the LiDAR and then the camera itself has its separate power supply, but I'm taking it off the CPU here, off the power hat.
Yeah.
But
I was going to say you can get one of those. You can get I don't know what the right word for it is because there's a couple of different versions of them, but you can get a PD spoofer basically. That sounds like what you've got there, where it actually tells the Pi that yes, I'm asking for 5.4 amps at 5 volts at 4 amps? I can't remember their specs.
It has to be at least 5 amps.
Yeah, 5 amps. It'll actually negotiate with them. And it sounds like that's what this Pi 5 PD power does.
Yeah, there's a few battery banks that are like for recharging phones and stuff. Most of those will not cut the mustard, but there are a few that are what's called PD rated that actually will succeed in that negotiation. But there has been a problem for a lot of people with the Raspberry Pi 5. It just complains it's not getting enough oomph, and it will start to hold back on you.
Yeah, that's a. And do you have? Well, I get that's a Geek Pi. That looks like a really useful board there.
Yeah,
it really is. And the specs for it are on my website. So
that's not yours, right? That's a commercial product.
Yeah, it's a commercial product, but the specs for it, you go to a product link, it'll take you to the source.
Okay. Could you grab that link and throw it in the chat?
Sure. And you also get these at Amazon, but I will throw this in the chat, and there you go.
Thank you.
Yeah. And we were talking about wood. My favorite medium is acrylic because I love the transparency. Because when you have all these electronic boards inside, you get to see all the on lights and get the blinkies and all that stuff. And it's having a transparent chassis. It lets you see those things, like when you get an error indicator on the Roboclaw motor driver, you can see that.
That's 1/4 inch.
That 1/4 inch top and bottom, and then the side panels are 3/8 inch, so they can drill them on the ends in order to have thumb screws to be able to hold them in top and bottom.
Yeah. So when I started, I made stuff out of acrylic, but we used to have a contest where the robot would stay on you had to keep it on the table. Well, I had a couple of exciting experience with that, and the effect was it kind of shied me away from acrylic. I like the the 3/8 inch, what is it, masonite board. I find that to be easy to cut and also it's very, very sturdy. But quarter inch,
Yeah, I wouldn't
I
use
never
this
did
for a
make it in
table pot.
quarter inch. I usually used 1/8 inch.
Polycarb will survive most table faults.
What was that?
Oh, yeah,
Kareem? I
if
didn't
you're-
catch you.
Polycarb is much tougher than acrylic. It won't shatter so easily. So, you know, when the robot falls off the table, there's a chance it will survive.
Kareem, I didn't catch that. Did you say,
Yeah,
were
me
you
neither.
talking about Lexan, or are you talking about something else? Kareem?
He was mentioning polycarbonate.
Oh, polycarbonate. Oh, yeah. Yeah.
I believe that Lexan is a form of polycarbonate.
Lexan is a brand name of polycarbonate. Yeah.
Any other questions
Well-
before I duck out?
Jim, if you can't find a belt for your thing, okay, this is a size 19 bag of rubber bands. Works pretty good. I tried to get one. I couldn't figure out which model I had. And
I did get some from AliExpress. It came in two sizes, sort of too big and too small, but the too small managed to stretch around it and do it. But direct drive is the way to go.
Oh yeah. I have an older one. Came out of a Nido, and there was a club member that was selling a little control board with the LiDAR, and worked pretty good until I pulled it out and there's like 5 or 6 pieces of the belt just sitting on the thing. So
Yeah. Well,
and I tried to buy some on AliExpress, but same sort of thing, not the right size, and couldn't tell which model the LiDAR was. So
well, I noticed that you're not using you tried to use a USB hub, a powered hub, and stopped using it.
Yeah, because it didn't give enough power to handle the. I started to try to put the Raspberry Pi in there. I powered the USB hub with the 12-volt battery, but even though it says it could put out 5 amps, it really can't put out that much to all 4, 5, 6 ports, and it just wasn't up to the job for a Raspberry Pi 5. It probably would have handled the camera and a few other things, but it really couldn't handle the Pi, so I went a different route with the power hat.
Okay, yeah, because I used a similar powered hub, but I powered the Pi separately than the power to the hub. So the Pi was powered directly, and then the hub was powered directly.
That probably would work.
Yeah. Okay. I was just noticing. Yeah.
Yeah, I have a question on the belt drive for the Nido. If and it's just because I don't know materials, but if you know the approximate dimensions, is there a chance you could just print something out of NinjaFlex or some material like that?
Yeah, it's an idea.
Another option is if you got enough of one where you can tell how long the belt is, you could probably get O-rings at Grainger. And, if you get the, neoprene ones, which are very inexpensive, you could probably get 100 of them for, $10. So, I'm just saying, if all you got is 6 little pieces, Ray, you're pretty well screwed. But you could use a string, and measure it.
Yeah, that's true.
But you might look at that. Just go to Grainger's and take a look at their O-ring selection.
Okay.
I'm surprised that they wouldn't be available on places like eBay and Amazon. I guess, if you measure it with a string and roughly whether it's kind of the right size, probably can get them off of those.
Yeah, it's kind of weird. AliExpress, you'd think that'd be a thing they would tell you, okay, what's the diameter of that belt? No information about it. It's kind of like, okay.
I hate dealing with, products that you're just kind of guesstimating on,
Mm.
There's another idea. How about if you take the model number of your Nito and you ask a GPT what different people in the community have done to replace the belts?
Yeah. Yeah, I don't know what that model is. It came from James LaCroix, or I think that's who it was. Anyway, he had a bunch of Nito robots. What model? I don't know, and I don't think he ever told us what it came out of. And
you might be surprised if you have a serial number on it or anything like that. Nitos have been, used during the period when they were super popular. They were used a lot, and so there's probably a lot of information on the web, and there's AI. You could just ask.
Yep.
So
Kareem just posted a video
link there, huh? Okay, cool. I'll take a look at that. Yeah.
And
yeah, it's kind of like Jim said. There was a set, so and it was one was too small, one was too big, so it's kind of like So, I actually tried the rubber band. It seems to work okay. So
it doesn't have much load on it.
No. So it's got enough stretch that. And I didn't realize there are that many variations in rubber bands. You should go to Office Depot sometime and take a look. It's like there are a zillion sizes. So, okay, yeah, that's cool. I'll take a look.
I think it was the wrong kind of thing. I think that was for the side brush belt.
Okay, now I got to ask, how come Kareem is in yellow?
Oh,
I'm yellow.
Yeah,
Trish is Ed Mart.
I'm an admin now too. So.
Yeah. Well, I mean, I believe Pat's an admin too, so I'm just surprised. All of us other suckers are blue.
I'm green.
Yeah, you're green. Okay, I don't know. Obviously, there's some theme thing going on. Okay, I'm just curious. I thought everybody was blue.
I'm just better than you, man.
Yeah. I don't know. I'm more restful.
I'm all yellow.
Any more questions for Jim?
No, that was a great robot, Jim.
Thanks.
I'm sorry I came in a little late. Where's your location? Are you?
Oh, I'm in Houston.
Oh, you're in Houston. Okay.
Good.
I'd love to have you up here for one of our Robo-Ramas. That looks like that would be a great robot.
Would love to come. It's only about a 4-hour drive from here.
Yeah.
My daughter used to go to SMU, so I'm used to the trip.
Yeah.
I've been to Houston about 8 times, but only at the airport. Fly through Houston to Shreveport.
Yeah.
The Kareem posted another link. Next up, we had Mike. Apologies, Mike. I had you ahead of Jim actually, and I jumped the gun. So
yeah,
you're next.
The new people first. Yeah. So can't tell. Go away. So I redid the body of my my robot, and
nice.
Kitty Cat's interested in it. Yeah, and so before the wheels were like in the middle, and so someone lifted up my front and lift up the wheels. So now the wheels go to the very back, and so when it gets lifted up, I still get traction. So if someone comes, this is a Mini Sumo robot. So if someone comes and puts something under me, I'll still have traction, which is pretty important.
Yeah.
So that was my big change. Also, I took out the back sensors because I couldn't put line sensors in the back or edge sensors because the wheels are there. And there wasn't any room under here, under the motor.
I don't know about that. That sounds like a mistake, Mike.
The back line sensor or edge sensors?
Yeah, because if you're in a, well, I don't know. It just seems like you want one back there in case you accidentally go out the backside.
Yeah, but I don't.
This thing has reverse, right? Do you ever go in reverse?
I mean, I always go forward or spin, but yeah.
Okay. Well, maybe you're right.
But I would like to put a sensor right there just so that I could.
It'd be all over, but the pry in there. That wouldn't be worth it.
So when it comes off the Sumo mat, then it hits the table on the floor, all 3 sensors would detect and it would stop. Because I had it before where, I'm not on the black air, I'm not on the mat anymore. So
well, it looks like you're giving it a real college try. I'll be interested I'd love to see somebody beat Scott at his own game there.
Yeah. So I measured. I went to the Dallas Makerspace because when I printed this at home, like I have like a millimeter between the wheels and the plate, bottom plate, and I changed some adjustment. I printed on a raft this time and made some adjustment changes. And when I got it back, I think it had a bulge in the center here, like sort of the center of it fell down a little bit because of the raft, and it was basically not getting good traction. So I took it to Dallas Makerspace and sanded it down, and to try to flatten it out and make sure so that I have a good flat surface here. I need to really print it on a really good printer at Dallas Makerspace because my printer at home is a 15-year-old row stock, printer, and those are really hard to get level. So that's why I put a raft on it. So that's.
Have you tried a brim? You do raft or brim?
Oh, I do brims. Yeah.
All the time. Yeah.
Yeah. And just to try to keep it from lifting up and stuff. And this is, and I weighed it at the Makerspace and it was 420 grams. So I'm a little shy. So if I show this here, let me see if I can share this screen. Hold on a second. Share. Oh, here's share.
I don't mean to volunteer anybody. I could volunteer myself. I got some printers.
Yeah.
I mean, literally everybody you're looking at here probably has a printer close to them. Well, maybe not everybody, but pretty much.
Yeah. So this is my this is my weight right here. I put a little area here to put some weight in, and my pennies. I filled it up with pennies and could only get to 420 grams. And I've ordered some lead shot that should fill it up more dense with heavier material. So I think I can get it really close to 500 grams. So, and I have a little slot over here. I found another spot where I could put in more weight. So I'm hoping that when I put shot in here and fill this with shot, that I can hit a 500 grams to get my full weight to help with traction. So.
Titanium, I think, isn't that the most dense material that's not radioactive?
No, titanium's very
It's light.
You
Oh, it
want
is?
tungsten.
Lead is much denser.
Tungsten.
Yeah.
Osmium is the densest I think you can get.
Which one?
Yeah, osmium.
Osmium.
Oh, okay.
But, you just go for
I
lead.
thought one of them was
That is
supposed to be
toxic.
denser than lead. I didn't think lead was the
Osmium
densest.
is and tungsten is, but not titanium.
Osmium's quite expensive.
Yes.
Yeah.
Crazy expensive.
Lead is super cheap.
I'm serious.
Yeah.
Why not? If you will provide filament, I can print it for you. I mean, I've got 3 of them sitting around here. 2 of them aren't doing anything.
You can print lead.
Print some lead? What?
Print some depleted uranium.
There you go.
Pretty dense.
Now, wouldn't lead disqualify you from the reduction of hazardous materials?
Just
Trying to get the lead out of solder.
I've got some. I've got
just
some
pot
dog
it
over
with
here.
just
My
pot
dog's
it
about
in
more
epoxy.
dense than lead. You know, my dog's way denser than lead, but I don't know if it fits in your robot though. Okay, never mind.
Pot the shot with epoxy. It'll lock it in place and seal it.
Yeah. So the pennies are down here, underneath of the battery. But tomorrow I have some lead shot coming in there, 3 millimeter lead shot balls, and that should fill this up real tight. I think I can get there. I might even be overweight, but it's easy to take stuff out. So
I was gonna say you could cast it, melt it down, form the right shape. Yeah.
I could, but I just put them in there loose because I made it so that when I screw the top and bottom together, it's sealed, so it's good. And then you can see I put the sensors down here, and then they get sandwiched between the top and the bottom. These are the edge sensors. So I'll stop sharing, and then
do you have the pots? Are the pots available through the bottom of the robot?
Can you see my robot?
Can you adjust the pots after you have it sealed up?
Yeah. Can you see my robot?
Yep.
Yeah. So
give me a second. I have to make it.
If you can see, I have holes right here. I got holes for all the pots on these.
Gotcha. I see it now.
So the screwdriver goes down and connects to the so I can make an adjustment.
Gotcha.
So I was making sure I had holes for everything. I have a hole here so I can get to the processor to press its switches, and the RP2040 has a really nice RGB LED on it, so I can see the status of what's going on. So, and then there's a hole back here for my USB port.
Yeah.
And a hole here to access my battery to be able to pull it in and out. So if I do this, let me see if I hold on. Okay. The wires. Come on, come out. Here's my battery wire. So that's how I change my battery out.
Gotcha.
Yeah. So that's that. And then I have another project I'm working on.
Before you leave that one, I've heard of some people using like a cooling fan to create a vacuum under their Sumo robot for extra traction.
Yep.
Yeah, I've heard of that. Yeah. I'm just using lead shot. So
we just want robots to compete first, Jim. We have one gentleman who has, I think, 3 robots, and last time he got first, second, and third. So we gotta kind of share the wealth this time if we can.
Okay, so my project I'm working on, I'm reviving it because the artist needs it for a show, and what this does is I've redesigned it to use a big bearing like this because it was it was leaning from the wall, and so now I've solved all those issues. I have a huge bearing, so it shouldn't be leaning from the wall anymore. So the painting would be straight up and down, and so you can see then this middle part here is going to connect to the base, which has the motor and everything. And if I have so if I bring this up to this one here, Yeah. This is his. This is what it looks like rotating on the wall, if you can see that.
Don't
Not
see it.
seeing anything.
I don't see it yet.
Oh, I'm not sharing. Oh, crap. Okay, hold on. Here it is. Nope.
Yep.
Cool. Now, the bearing, Mike, is that a commercial product or is that one that you constructed?
Oh, the bearing is commercial. It's just like a Lazy Susan type bearing. So this is an 8-inch version, so it's 8 inches.
But I mean, that's a 2 aluminum rings is what I think I'm seeing.
Yeah, 2 aluminum rings with ball bearings inside of it.
In between.
That's pretty nice. I'm curious. Do you have the link for that by any chance?
I could find
They're-
it. Yeah,
They're
yeah.
cheap. You can find them on Amazon.
Yeah, they're on Amazon, cheap. Yeah, like that was like
Okay.
12
I mean,
bucks.
I've seen Lazy Susan bearings before, but they're never quite that nice. They're more
Oh,
like,
Hmm.
yeah, not 2 aluminum rings. They, the 2 stamped pieces of metal. I've seen them,
Yeah.
but the aluminum ones look like they might be lighter.
So let me
Ooh, that's
I'm
an
gonna
ugly
share-
link.
I'll share my CAD file on this project here. Let me see. Here it is. So this is the CAD file of it. So you can see that the bearings here, and then that top thing you saw is here. And one of the solutions I came up with is we're having a hard time figuring out how to mount it to the wall. And I found something called a French cleat, which is a picture hanging technique. And
Yeah.
I didn't know about it.
They're called Z bars also.
Okay, yeah. Yeah, I wasn't aware of it, so I started Googling. I need something, and then I finally found out that is it. So this is going to be the way that this whole thing mounts securely to the wall, so it doesn't lean and everything. Before it had like picture hanger wires and stuff, and it would just sort of lean. and so if I get rid of this, yeah. So this here is so there's a circuit board here with electronics, and then this is the motor, and then this is the coupler to that frame. That big cross frame is just big so that you can screw it onto the back of a painting. So it's a good project, and we're just having trouble with the stability of it, because before I was just hanging the painting off of this bearing. This has a really nice bearing inside of it, but it was just mounted to this, and it was doing pretty good, but then it started moving because it's all plastic, 3D printed. And so that big, huge bearing that's mounted securely to the wall should keep it from doing the issues it was having. So, yeah. So if I take out these, like I have a bearing, so this thing has bearings that go into here to relieve some of the stress off of the motor shaft. And so if I take off the so this right here is the motor. And so that motor shaft, I was trying to get all the stress off that motor shaft, except for rotational, and that other bearing was doing it, but it was not really handling a big painting. It was sort of like just acting up funny. So I think he's going to be happy. I'm going to be happy with it because he'll quit bugging me. So that's okay. Well, I'm going to stop sharing this.
I don't know, Mike. I suspect that once he sees it, he'll have a couple of suggestions. Why is it rotating so slow?
Oh, he wanted to rotate slow. In fact, it could go much slower than that. And I thought he wanted to do like 1 revolution every 2 minutes or something. And so I geared it all down to do that, and he wanted it to go faster. So it's like, but I gave him a control. It has a remote control, a little remote control thing with a RF, and so you can set the speed to whatever he wants to. And he wants to sell it as art, and so the owner would get that remote control. They can turn it on and off, and they can set the speed whatever they want. And they can go forward or backward, so it can change the direction. So it's just a motor with a motor controller, right? So yeah.
Who needs Boston Dynamics when you have Mike building these things?
Yeah. So that's a nice project. But I was really bummed out because I couldn't really figure out the mechanics. But finally, the mechanics clicked into place with using that French cleat. It's like, now I feel good about it.
Well, that's cool. Thanks, Mike. Next up, we have Ray.
Oh, okay. Well, I've been working on beacons, and I'm going to see if I can get my phone up here. Get it on the website. DPRG website.
Oh my word, guys.
What?
I'm sorry. I was chatting out loud to I'm cleaning up a 3D model of something for a friend. He doesn't even know I'm doing it. I'm looking at what they did with it.
DPRG website.
Oh my word. What are you doing there for?
Robotics groups.
But one thing I've done on my projects now is I've gotten the 3D metal inserts, threaded inserts. So I've been learning how to use those to get better connections.
Yeah, once you go heat set thread, baby, you don't come back.
Yeah, so this thing here, I wanted it to be really sturdy, so I put like 4 millimeter threads in here. So
he's killing me. Let me mute myself. Hold on.
Or you could just drill a regular hole and tap it.
Jim?
Mm-hmm.
What did you say?
You could just drill an ordinary hole and use a tap to put the threads in, depending on what kind of material you're dealing with. You know, if it's metal or acrylic or something, substantial.
Yeah. Well, this is like 3D printed PLA.
Yeah.
It holds okay, but it's put some weight on it and it deforms easy. Yeah.
Those heat sink inserts are really cool in the right place, but it takes a certain finesse to get them in right.
Yeah. Yeah. My first one was pretty crappy, but that was my test. And then I sort of learned how to hold the soldering iron straight up and down when I'm pushing it in. And then drill the right hole size, and then a little cone at the very top of the hole to give it some place for the plastic that oozes out to go into. So.
The ones I always have problems with is the plastic oozing in the back end. If it'll. So you put in your insert, and the fill will actually ooze into the back of the insert. So, even though you have your soldering iron inserted all the way through it, it's still seems like I occasionally get them where there's like a block of oozing plastic in the back.
Yeah. I've been haven't had that issue yet.
Yeah, if I drill through it, then that's not an issue. It's usually when I'm doing it into a blind hold.
I make my holes really deep, so yeah.
Okay, we got something.
Okay, can you unpin me? And I'll show
Unpin you. Okay,
Say it again.
just trying to figure out what
Are
you
you
got,
sure you're
Ray.
seeing?
Okay, so this is basically a 3D printed shield that holds 18 38 kilohertz receivers, infrared receivers, and they're 20 degrees apart. There's 18 of those, and this is actually going to go on the robot, and then let's see if I can actually show it to you. It's pretty small. On that prototype board is a 315 megahertz transmitter, and in the four corners of the 6-can course, I'm going to have 4 corner transmitters. So they're actually going to receive a pulse width through RF of a certain width. In this case, it's like 400, 600, 800, and a millisecond. And each corner is keyed to look for a certain pulse width. So when it sees that pulse width, it will turn on the infrared transmitter. So they're going to go round robin. The robot's going to tell each corner when to transmit or when to turn on its infrared transmitter. And so basically, through triangulation, it can figure out where it is on the course and what angle it's sitting on. I guess that's just pose, or called pose. Anyway, I don't have all the pieces that I need right now. I only had two transmitters and 2 receivers, so I can't do the other 2 corners yet, but I've got some stuff coming. I tried it with 2 and it seems to work pretty good. What it does after each corner receiver starts to transmit 2 1 millisecond bursts of the 38 kilohertz, and the infrared receivers are scanned on the robot looking for that pulse. So when it sees it, it actually accumulates the number of times each sensor has been seen. So you can, the ones that are, where the IR light is hitting directly, will have more hits. The one that's kind of on the periphery or being shielded by the little fins on this. I don't know if you can see them actually in there or not. Maybe I could turn on the light.
We can see them.
Oh, okay. Anyway, so there's, like I said, 18 of those. But so far, it seems to work pretty good. It's pretty fast. Each, with, I guess each cycle for each corner is only 4 milliseconds total. So, that fits nicely in with a 50 millisecond like cycle time on the PID loop. So I could actually do that, 3, maybe 4 times at the most, and have it still, have enough time to do the PID loop. So.
Okay, I'm having a little problem, Ray. I'm a little confused. I understand that you have 18 sensors that are in the circle.
Yep.
And that they, depending on which one gets hit the most, I assume that tells you an angle. But where is what are the corner? I'm a little confused about where the corner ones are. Oh, you're going to put, are these outside the arena on the corners?
Yeah, they're just on the where in the okay to put sensor zone.
Yeah. Okay. Okay.
So
So
in
now
each
I'm getting it.
corner.
Okay. Ah, cool.
So-
Hey, that is clever. I get you. So you're gonna have 4 individual modules sitting
Right.
on one on each corner.
Yep.
Okay.
Yep. So yeah, each of them. I had one over there that's pieced together, but the other one is actually back over here, just sitting on a proto board. So that's got the RF receiver and the IR transmitter, and
How do you know which transmitter is transmitting or is being received? Or are they all just blasting all the time?
No, there's an individual pulse width that is, it's like a pulse train of 400 microseconds on, and let's see what the before. So 46, it's like a 5 millisecond window. So the on time is 400, 600, 800, and 1 millisecond, and the off time makes up, a 4 millisecond frame, I guess is what you could call it.
I'm asking what differentiates signals coming from beacon 1 versus beacon 3.
Oh, well, the robot sent out a pulse of a certain width, and only that one beacon will respond to it. So it knows which pulse it sent out.
So you're sequencing the beacons around? Is that what you're
Say that
doing?
again?
You're sequencing the beacons
Yes.
in order or something?
Yeah. Just in a circle, round robin,
Okay.
and continuously, and every basically 4 different pulse widths are sent out. The corner receivers recognize that, and each one will respond to just one pulse width, and so then it will transmit back to the robot, back to this thing where all the infrared receivers are, and it'll hit. I don't know. Right now, it's hitting or able to scan all 18 of them about 7 or 8 times in that time frame. So the ones that see the most IR will have the most number of hits, and the ones on the periphery, maybe they're just an angle, so very little of the IR is getting in, and it doesn't always catch it. Will hit less often. So basically you can say, okay, I've got a distribution of pulse widths. Which 1 or 2 have the most hits, and that should correlate to a direct line of sight or more direct line of sight, versus the other ones that are, say, off at an angle or being shielded by these fins, may not get as much infrared. So and it seems to do okay so far.
You can calculate where the XY position inside of the arena of the robot is.
Yeah.
Okay.
From where.
With what level of uncertainty?
According to Copilot, it's going to be about 5 degrees.
Well, so 5 degrees, but then from 5 degrees to each beacon.
No, 5 degrees for the from the actual pose of what the robot's sitting in
the rotation.
Wait, so you're only are you only doing this for rotation, or are you trying to get XY coordinates?
Yeah, position in the course and orientation or rotation.
So I'm asking, what's the XY fuzziness? Assuming you've got at least 3, right? If you've got at least 3 beacons that you can see, then you've got actually, technically, it only requires 2, I guess.
2. Yeah,
maybe to get a fix. But with a 5-degree variance, it could
Yeah.
be a pretty big area. I don't
Maybe
know.
like 10 centimeters or something like that.
I don't know what that is yet, but you know, I asked Copilot, you know, because I was more concerned with how accurate the angle was, because I actually started out with just 8 receivers on it. This was a oops, where am I? There I am. That was the first one, and then I decided, you know, to go to 18 basically to get the resolution down. This was you know, one sensor every 45 degrees and the other one's every 20 degrees.
You could put it on a servo and move it around.
Well, I didn't want to, anything mechanical takes a lot longer. So, you know, if I could scan it electronically, is, you know, pretty much reading them one after the other. And it's just, I'm just looking for a low level. It's not like I have to have a burst of a certain length or anything like that. It's just, you know, scanning one after the other, looking for a low voltage level. So
are the transmitters are sending out some signal pattern, right?
Kilohertz. Yeah, 38 kilohertz, 1 millisecond pulses. So each one does a millisecond on, millisecond off, millisecond on, millisecond off. And
yeah, I guess what I'm getting at is, you know, if you think about a TV remote, okay, you know, you can point a TV remote in any direction and the TV will come on and come off. Now, by putting shielding like you are, you're limiting the access to the diode.
Right.
Yeah.
Or the sensor, yeah.
Yeah.
Yep.
But I'm just curious. So, well, Ray, this is interesting. This is definitely a different approach. So we'll see how it goes.
At this point, I've got to get some more things in, and I don't know if there's a thing that I can do to say, you know, use different combinations of the corner sensors or the heading to each corner sensor, to say, okay, this one says, you know, your, you know, orientation is, you know, 2 degrees. This one says 3. You know, do you take the average of those 2, or, you know, how do you improve that? And I don't know at this point, so haven't gotten that far.
But your 5-degree error, that's for a single receiver, right?
No, that's
for the combination of
using triangulation
using triangulation. Okay,
figure out what the angle is.
Any one receiver, you'd have a, you know, plus or minus 10 degrees if you've got a 20-degree field of view.
Right.
So it would take more than that to pin you down a little bit.
And unless there's backscatter on the fins, so that like the one in the middle might get the strongest, but either side might get a little bit less.
Yeah. So, and, you know.
Yeah, but are these hooked up to analog? Are they hooked up to A to D so you can see the intensity level?
Just 2 of them are. It just, the 38 kilohertz receivers just put out a digital pulse anyway. It's not like it's you know, any indication of strength or signal strength rather. So, but
if you get 7 samples per cycle, there might be like one gets 3 and the other gets 4.
Right. And it's supposed to do a weighted average to figure out which angle is, you know, has the most number of hits or the highest intensity, or just most number of hits, I guess.
You don't have an intensity, so it's just going to be whether it gets a reading. And if you'd have to like dial in your threshold pretty well in order to like make sure that you only get a reading from something that's dead straight on.
Yeah, with these, I don't think I can do it. It's a 3-pin device, VCC ground and a digital output. So The
So you could get returns from multiple of them, and you
That's
want
okay.
like
I'm just listening.
Well, I got a call from Bill and Linda that they want to come spend the night.
But that'll tell you, Kareem, right? If you get it from multiple, I mean, it seems to me that there'll be some statistics that say if it's coming from multiple, maybe the ones off to the side won't get every time out of 7. They might get less out of 7, whereas the ones closer to the middle will get more or all of the 7.
yeah,
So
that
then,
seems to be what's happening. I can look at the individual
yeah,
total number of hits, print them all out, all 18 of them, and it's like 1 or 2 in the very center will have typically the highest number of counts. So it's kind of like a distribution, like a bell curve kind of thing.
yeah. So it's
So
not an analog measure of intensity directly, but by the sampling mechanism, because some will be above. I mean, randomly, it's a kind of a crude way to quantize the intensity.
Yeah, so you can do
yeah.
some sort of interpolation, I suppose.
Right. So
yeah,
I think
I'd want to test that early on in the process to be sure that that's what's actually going to happen, right?
Yeah.
You can also get incidental reflections, and
Right.
those
Yeah.
are just because it's black doesn't mean it's going to absorb. And in
That's
fact,
true.
specular reflections it doesn't really matter as much what the color is.
Yeah.
It's going to happen, especially on a somewhat shiny material. You might want to consider some velvet flocking to apply to the sides of those fins. They appear very, very dark because of the
Okay.
soft,
Yeah.
rough surface.
Right.
Yeah.
Very absorbent.
Yeah.
There's also a super black paint you can get.
I printed my robot in flat matte black, and it's pretty invisible to the IR sensors. So
Oh, is it? Yeah.
so if you have
I could polish all the whatever it is, 18 fins on the thing.
36 surfaces.
but you can reprint with a flat or matte black PLA.
Okay.
Yeah.
Anyway, yeah. So the according to Copilot, it's going to do a weighted average of all the hits and per corner transmitter, and it bounces around a little bit, but I think one of the advantages of using 4 instead of just 2 is that I think the closer I get to the infrared transmitter, the more likely I am to hit several sensors, and then from that I can probably determine what is the central, where the beam's coming from.
Yeah. So I guess the main reason for this is 6 can when you're trying to go through the goal, right?
Yeah.
Yeah.
Yeah. Or just just instead of a compass and odometry, I should be able to say, okay, I'm at grid point, whatever, 20 centimeters, and I'm pointed in this direction.
Right.
And I'm going to go to, the center, and what's my waypoint too.
Mhm.
So,
Seems like a ton of work.
seems like a ton of work. Yeah.
Seems like a ton of work. I would just use April tags.
You did that last year.
So easy.
What kind of arena are we working in here? What's the contest?
Oh, it's a 6 can contest. Goal is you have a 7-foot by 10-foot soccer course or whatever course, and it's got 3-foot openings on either side, and the goal is to get 6 randomly placed cans into your goal. So it's a time contest. The person that wins gets the cans in the least amount of time. And then we have another one that's can where 2 robots go after the 6 cans, and whoever gets 4 or more wins. So anyway, so it's,
2 beacons would be a problem is when you get close to being in the midline between them, then you don't know your directions. You need a third point at that point. If you're right in between two, you can't tell where along that line you are. But if you have a third point, then you can tell by
Oh yeah,
triangulating where you
I'll
are.
have 4. So, and it takes very little power to to run 18 detectors, and it takes a little bit more for the transmitters. What I was thinking of doing was having each corner cover full 90 degrees. So I'd have one at 90, one at 45, and one at 0 degrees. And it would shine, pretty much all across its corner. So there wouldn't be any dead spots, because they definitely, they say they have like a plus or minus 45 degree, dispersion pattern. But I found if you get, a little too far off that, the distance that it can actually detect it is less and less. So less than 10 feet. So
What about reflections from the wall?
that is a possibility. I haven't tested that. So,
You might just
And the
light up the
ceiling
whole
and-
arena.
yeah, the whole arena could just be a
Bright IR.
Optical echo chamber, just bouncing light all everywhere, But I'm actually going to have it above it, so I'm kind of hoping that there's so little reflection coming back that it's not going to see it. But I don't know if that's going to happen or not. But anyway,
The
always
walls
wanted
are
to do
white.
this. What's that?
The walls are white.
They are,
Well,
and kind of reflective, so
And shiny.
Wait,
And are they white and reflective and shiny to IR?
probably. But, yeah, so I've got a course, and I'll check it out and try it out. It may be one of those things that hits the garbage can or goes on the pile of, well, that sounded like a good idea initially.
Is there a rule against applying Cream's anti-reflective material on the walls of the course before you run?
Yeah, that's a thing. So an extra little coating on the top. So.
Have you thought about shrouding your transmitter diode so that it only goes out like a brass tube or something, so that it would be a very narrow beam?
Yeah, but then in areas where the beam isn't, I won't see it, because it's only going out in one direction and one angle.
It's to be seen from anywhere in the arena.
Okay, yeah.
Yeah. Yeah.
So you got
And that's why I wanted to have like 3, like over here, I've got, 3, 3 transmitters. Right now I only have 1 hooked up, but this is, that's what I want to do for each corner transmitter, is have 3 at an angle. So it kind of covers,
okay,
pretty much all
That's also not the way light works. You can't just put it through a tube. It'll still end up diffracting and spreading out. You got to use a lens if you want to focus it.
Okay.
Or a laser.
Yeah, put a laser on a servo and aim it at the robot.
Yeah, see, I didn't want to do anything mechanical because it's just too slow. I wanted to get under the 50 millisecond update rate for the PID loop, and
If you use a LiDAR, it's a lot quicker than that.
What's that?
You can use a LiDAR and tell you where you are.
That's true. Yep.
If those are all
If your
conventional.
surroundings are, yeah.
Those
This
are
is
also
at least
conventional.
unique.
Though. Yeah.
Oh
Unique
yeah.
style points.
If it works, it'll be great. If not, it's just unique. So anyway,
I've seen crazier things. I know one robot that has a sundial, basically a photo sensor sundial that tries to tell it what its position is by where the shadow of a pin in the middle is.
Oh yeah.
Photodiodes around the circle.
That would work, but this is inside, and there are no windows in the room that we do this contest.
Yeah. And that wouldn't work very well on an overcast day either.
That's true. Yeah,
it is a unique way.
That's
So this,
yeah.
This reminds me of the kind of obfuscated coding awards. maybe there should be some kind of obfuscated location positioning system awards.
There you go. This might qualify. So
Yeah.
depending how it eventually works or doesn't work. So
Yeah.
anyway, that was all I had.
So, hey, Ray,
Yeah.
you say it kind of works kind of good. Do you mean that the sensors turn on and turn off? Or do you mean that when it reports a position with whatever code you got right now, that always says the same thing because you're not moving it?
Yeah, there's kind of a range. It's looking like right now it's bouncing maybe 7 degrees, so I'll get readings, in a 7-degree range for both.
So does it like drift, or does it just every time you turn it on, it's a little bit different?
I don't know if I'm getting some sort of, like fluorescent lights can interfere with infrared receivers. So there may be something going on like that, but and I actually have the thing upside down instead of the way it's supposed to be. That's, it's upside. Well, it's just sitting upside down because it's easier to do that way. But anyway, I guess we'll just see what happens.
Yep.
So
It's interesting. I would like to see what happens. And that's kind of interesting.
Ray, what are you using to control to monitor and control the signals? What kind of processor?
These are just Arduino Nanos because I had several of them, and they don't have to have wireless transmission or anything else because I'm using the little transmitters and receivers, and they're dirt cheap. I mean, you can get like a pair for I think under $2. But yeah, I actually looked into using ESP32s, using ESP Now. But the kind of what I liked about these is there's a lot less variability. Like, with ESP Now, there can be like varying delays. So you can tell it to transmit or broadcast out. But there's, a certain amount of time that can take. And it can vary like, I think over 2.5 milliseconds. And it depends if there's like, collisions and that kind of stuff, if it needs to retry. So this was kind of the simplest one. There's a few, I don't know, maybe 100 microsecond delay between when the transmitter starts transmitting and when the receiver receives, but in the timing scheme, that's pretty small. I don't have to send multiple codes or special codes or anything like that. One of the things I was a little worried about was it maybe turning on and off all the TVs in the room all at the same time. But I don't think so, because that's like a more complex code that you have to send. There's I don't know, like it seems like 5 or 6 standards. I think NEC had one that seems to be the most popular, and I don't know, there's like several out there that have been used for like television sets or.
Yeah, those are surprisingly hard to spoof.
Oh, they are, huh? Okay.
I'm just trying to make an IR
codes.
blaster to just mess up with TVs, and you have to send the right signals or it doesn't do you any good.
Yep. Anyway.
It's like the TV manufacturers know that somebody might want to do this.
Yeah.
Or a bunch of TVs. Who knew?
Who knew?
Yep.
Yeah, planning for Ted to not jam somebody's remote control. That's impressive.
I think Adafruit had a thing where she got tired of all the TVs blasting, outside, so she made something so that she could turn them off.
So yeah,
Anyway.
going back to the original goal of this is to get the XY position of a robot in an arena. Other than like RTK GPS, what is the common way of doing this?
You can use odometry is probably
The
most
simplest.
common. Yeah, the simplest.
The simplest is odometry, but
Yep.
and then probably the next one is odometry using a gyro
Mm-hmm.
instead of the actual wheel encoders.
Yep.
The problem is encoders drift and gyros drift, and not that they can't be done successfully in this contest, because I've done it successfully in this contest and other people have too. But there are other ways that are better. Somebody mentioned, probably LiDAR is probably one of the more elegant ones.
Mm-hmm.
Okay. But
yeah, I used to have a,
But
It
another
was,
way you can do this is you can have 4 distance sensors, forward, back, left, and right.
Yep.
Okay. And they kind of do what Ray's doing here, in the sense that instead of kind of find what direction the robot's turned in, what they do is they tell you what the distance on the pose of the robot are in the 4 directions.
Yep.
And then from that you can figure out where the walls are, and that's another way of doing it.
Yeah, you can use ultrasonic sensors for that.
pretty much anything to determine where the walls are, where the
I'll be
openings
quite
are.
honest. I used, when I first started out, I used ultrasonics quite a bit, but I really hate using ultrasonics. They're great for when you need to know a wide, like is something in front of me, that they're great for that. Okay. Cause you don't care whether it's to the left of you or the right of you so much. You just know it's in front of you somewhere. Where if you use a TOF sensor, you got to be aimed right at it, or you'll miss it. And so there is still use for them, but if you've calculated it out, if ultrasonic, if you're close to your target, they're very speedy. But if you're far away from your target, they're very slow.
Mm-hmm.
And so, yeah, because they're based off of sound.
Mhm.
So sound travels
Smooth
pretty
sound.
slow. So, you just have to make up how you want to go on it. So what I'm trying to do, my newest robot, is TOF in the 4 directions and an ultrasonic in the front for just general, okay, your TOF missed something and you got something right in front of you. You know what I mean?
It's like a
So,
light stick.
yeah. So we'll see how that goes. I'm still playing with it.
Yeah, one of the other things you can use is LiDARs. Like this was mounted on a servo on some of my first robots. That's a pulse light. Garmin owns it now. I'm not certain what they call it, but that's a pulse light version 1 and version 2, the silver one and the blue one. And but it's slow on a servo. I mean, it works, for like, I think they said 40 meters, which is way too long for a 10-foot course, but it worked very well. So, but it was slow. And so I'm trying to get rid of anything mechanical, do it all, electronic. So anyway, that's all I had. I'm going to get off my phone.
But it's pretty innovative. I like it.
We'll see. That sounds interesting.
Okay.
I hope you get it where you can show a demo on it, Ray. That would be neat.
Can you hear me now?
Yeah, we just heard that.
Okay.
We're looking forward to a demo, your next update. Next up, we had Ted.
All right, so yeah, last time I talked to you guys, I was working on mounting a magnetometer on a mast on my robot, and I was having trouble with interference, static electricity, I think. So yeah, there's the robot, and the big round one is a GPS antenna, and the smaller one in the back over here is the magnetometer. So I took all your suggestions. I shortened the cable to 18 inches. I put some grounding straps down the tube with the wiring. I put an aluminum foil, basically a Faraday cage around the sensor, and all of that helped. But the main problem was at my desktop PC. I've got a chair with one of those acrylic mats under it to allow it to roll, and that was acting like a big capacitor. And so every time I plugged it into the computer and started messing with it and picked it up, it would give it a shock and cause problems. So taking away the chair and the mat fixed the problem in the end.
Okay.
Fairly simple.
I thought you were going to say none of our suggestions
Hey,
worked.
Ted, can you give us a little look at your robot again? Because it looks pretty cool down there.
Yeah. So let's see.
Ray, that is exactly what he said, by the way. None of our suggestions worked.
None of our suggestions worked.
Well, they did seem to help.
It's true.
So
Getting rid of the mat worked, you know.
I have a bumper here on pivots, and it has switches, so I can tell if it hits the left side or the right side. This is one of the Garmin LiDAR sensors, and above that I have a OpenMV camera. Let's see, in the back, this thing weighs a ton, but I have a 6 amp hour lithium iron phosphate, and then I have a 6 volt 18650 battery pack. So this runs the electronics, and then I have a couple of ring sensors and a few other, or not ring sensors, but ring LED and a linear LED here for just for general output. What else? So it runs on a Teensy. Oh, I've got the wheels on a rocker here. Let's see, the front wheels here are just fixed. These two are have a belt driving them together. So it's kind of articulated to get over rough terrain.
2 motors, Ted? 2 motors?
4 motors.
4 motors. So the front wheels are powered too.
Front wheels are powered, and then the back wheels are powered.
Okay.
So this is the motor here for the back, and the front motor's underneath there somewhere.
What motors are you using? Those look pretty beefy.
Yeah, they're beefy. I'm using the
Are they Andy Mark?
they're, what are they called? Not
The
yellow,
Go
they're
Builder motor?
the Yellow Jacket motors by what is it, Actobotics? One of those.
Let's go build a, yeah.
Go Builder, yeah. And then I'm using a RoboClaw for the encoders. Let's see. Under here. So, I have a little screen and a teensy control board in here. So let's see. Yeah, I don't think I really have it programmed to do anything right now, so not real exciting. And I have a screen on the back of the camera so you can see what the camera's seeing.
Yep.
And fairly good ground clearance there. Most of the parts are 3D printed with some aluminum extrusion from Go Builda also.
Yeah. Are those like 1/6 scale tires on it?
Yeah, I think so. Something like that there. I don't know. Let's see.
Maybe 1/10.
That big. So like, let's see.
Oh, probably not 1/6, probably 1/10, maybe.
Yeah, maybe 1/10. They're not all that big. See, about 5.5 inches.
Mm.
Cool. Boy,
Yeah.
that's a nice looking robot, Ted.
Yeah, thanks. Right now I haven't had a chance. Kind of took some time off over the Christmas break, and I just solved the problem with the magnetometer. So I'm hoping to start testing the magnetometer and see if it helped putting it up on that mast.
Does it have a snowplow option?
No, that would be nice. So it is a little small for snow plowing, but
Okay.
That's pretty good. You have it looks like a nice beefy rescue handle there on the top. I need to add one of those to mine.
yeah, exactly.
Yeah. Hey, Ted, ours was today was 77 degrees.
Nice.
Yeah.
It's actually been warm here this winter. It was in the 40s today.
Wow.
It was warm here today too, 32. That's Fahrenheit, not Celsius.
T-shirt weather, right?
Yeah.
Thanks, Ted.
Yeah.
Next up on the list, we had Harold.
Oh, cool. Hello.
Hello.
You guys can hear me. All right. So I have a very simple question. At least I think it's going to be simple. But I have noticed that on the Facebook Marketplace, those really cool $100 robot chassis and things are up there still. I'm guessing those are still available.
I think yeah. Are you talking about the Robo-Mowers?
The Robo-Mowers, do we have any thoughts on those? That's my question.
Is Paul still in the call? He might know.
Yeah, I think Paul was the one that might be the furthest along on it. I have one, but it's still in the box. When I started looking at it in detail, it's not going to be a drop kick, simple type thing to get it to work right. If you're not doing it, if you want to make a robot out of it, you know what I'm saying? It's still pretty complicated. But we'll see. It's you know, for $100, it's probably a good start.
I got you.
Yeah.
It's got some wheels and things and some structure and.
Well, you know, you got two motors.
I think does it got motors? I mean, that's one of the.
It's got two motors. I think they're pretty nice motors, but there's no encoder on them, so you're gonna have to fabricate your own encoder.
Yeah.
There's two brushless motors on it, so you know that's another potential motor source. They use those to drive the blades. So how powerful they are, I don't know.
I got you. Well, you figure they have to have at least a little oomph. I mean, they might not have a ton of torque, but they have something on them to get them spun up, right? They got to have enough.
Right. Well, they have to, yeah. And I like I say, you know, brushless motors are a little different. I think you need to know what the wattage is to kind of get a feel for how much power you have. Anyway, I don't know. We'll find out. I'm going to tear into one here later, but there's a couple projects in front of that. So I don't know.
I don't know anything about having projects in front of other projects, and
Yeah.
I have no idea about that.
Yeah.
No idea at all.
Yeah. Well, you know, they're big. They're big, Harold. They're bigger than you think. They're the size of a regular mower.
Like about a 20-inch lawnmower.
Yeah, they're big. So, you know, if you think about your garage there or your studio, do you have a
it ain't running around in my garage anywhere near shape. If I had 20 inches of space somewhere, I'd fill it up with something else probably.
Yeah, that's what I'm saying. So you need to think about it.
Yeah, I mean, $100 is still $100, even though it's probably more than $100 worth of stuff there, way more. It's still $100 that I could do something more with than.
If you're filling up 20 inches of space, $100 would probably fill it all at once. Whereas if you had to fill it with a bunch of stuff, it would probably cost you $1,000 to fill 20 inches.
You know, I hadn't thought about it that way.
You can strip it down. Just keep the motor and wheels.
I know if I was closer, I would have looked at buying one.
Yeah,
that's really the only question I had. All that kind of stuff. Also, if Trish is still on, I'm interested. I did send in a form.
Yes. Yeah, I'm still here, and I saw that. I saw that you signed up and Mike signed up. So thank you very much. I appreciate it so much.
Okay. I didn't know if there was what the official acceptance thing was, and if there was any ceremony involved whatsoever. But you know, you got my email, you got my thing. I'm happy to help.
Trish, is that a opportunity that's already come and gone, or is it in the future still?
No, it is in the future still. And I'm sorry, I don't have a camera on this computer, but so my nonprofit is hosting a VEX Robotics Tournament on the 17th and 18th at the Irving Convention Center. And this one's a lot bigger than the ones we've usually done. We've got 92 teams coming from now 10 different states.
Wow.
And the rec foundation kind of changed the rules on us on who can judge. And so our judges can't have a connection to the teams anymore. And so some of the people we normally have judge are not able to this year. And so we're kind of desperately seeking anybody that can help.
Mm-hmm.
And this is the same, Doug, I think that you came and helped a couple of our teams get ready for Worlds last year, helped do interview prep with them maybe? Did you come with Paul and do interview practice with some of them?
Yeah, we went there and did an interview. So I don't know, are we still eligible?
Yes. Yeah, actually those teams have graduated that you guys worked with last year.
Oh, okay.
So yeah, if anybody's interested, what the judges do, you come in and you interview the teams and you observe them while they're competing, and there's a rubric, so you score their interviews based off of a rubric, and when you're observing, you kind of take notes that align with the award descriptions. And I'll give you all the award descriptions. I'm doing a virtual training session on Monday. If you can't make that, let me know and I'll figure it out so I can get you guys trained up if you're interested. It is really fun. I've been doing it for 4 years now, and it's my favorite school program. And it is the reason I don't get to build my own robots anymore, because I now spend all of my time helping these kids learn how to do it.
Okay, so what can you like say what the deadlines are? So deadline for registration to be a judge is what day?
It would be Monday.
This Monday?
Yes.
Okay.
Is that yesterday?
No, Monday, like Monday the 12th.
Oh, okay.
Okay. And the actual event is on the 17th?
The 17th and the 18th.
Okay. All right.
And you don't have to be here if you still are interested. We're doing a virtual scoring of their engineering notebooks starting, well, Monday the 12th in the evening. And that's something that you can do on your own time, whenever it's convenient. And it takes actually, you're not allowed to spend more than 20 minutes per notebook that you're reviewing. And then there's a rubric where you can score notebooks if you want to.
Okay. All right. Yeah, I've been out of town so a little bit, so I hadn't.
But 100 teams is a lot.
It is for sure. Yeah, we were really surprised that that many kids signed up. This is the first time we've hosted an event like this before, and we weren't even sure if there would be enough interest to go forward with it. So we were pretty shocked when 92 teams signed up the very first weekend that we opened registration.
So that's like 500 kids, right?
At least, yeah.
How many judges do you have so far, Trish?
17.
You're looking for more if possible.
Yeah.
Yes.
Guys, if you can help out in the Dallas area, I'm sure Trish would very much appreciate it.
I definitely would. Yeah, and part of my problem has been exactly what Doug just said. He's been out of town, so a lot of the people that we had kind of counted on, now that they're kind of back to work and after being out of town, they're like, "Oh no, I actually don't have time to do that anymore," and things like that.
So is it like each judge has 5 teams, or is it like 2 judges per team? Or
So
something like that?
the way that we do it is we pair up judges with another person who kind of complements whatever their knowledge base is. And then we've got an area set up where the teams will come to interview with you, just so we're not having to chase teams down. And per the Rec Foundation rules, we're only allowed to do 10 minutes for the first interview. And so they're gonna be lining up to come interview with you guys, and it really depends on how many judges show up. So the plan is for every judge pair to interview 8 to 10 teams, but there'll be some teams that don't want to interview because they don't care. They just want to compete and they don't care about judge awards. And there are some teams that are going to be really into it. So we'll see.
Yeah. Is this their like an early season contest?
No, we start back in August.
Oh, okay.
And so this is what we refer to as a signature event. And the reason that we did this is because the World Championship moved to St. Louis since the Kate Bailey Hutchinson Center has been demolished. They can't have it here anymore. And so since the World Championship left, there's a lot of teams kind of in this area and just our region that won't be able to go to Worlds. It's expensive. It's going to be a whole week that they have to miss at school. And so we started this event so they could still kind of have the experience of a big tournament without having to go to Worlds.
Gotcha.
I was doing a quick math, and it's like 10 minutes for 100 teams. That's like 20 hours of judging. Yeah.
No, because we're going to be the way that the interview tables are set up, so the plan was to have 8 judge teams interviewing at a time. And so I think when we worked it out, it was something like 6 hours.
Okay. Mm-hmm. That's better. Yeah.
Yeah. So I'm going to put my email in the messages in case anyone is interested.
Okay.
Yeah, the Canada guys could do the remote stuff.
They can.
Yeah.
I will be driving.
Yeah, don't do this while you're trying to drive. Their notebooks are actually pretty cool too. Okay, that's all that I had. Thanks, guys.
Hey, thanks,
Trish.
Thanks, Trish. Good luck with your recruits.
Thank you.
So that was it for our presenters. We can open it up to roundtable discussions.
I got something I wanted to show, just in case. This is something I just came. Now, everybody might know about this, but I didn't know about it, and type of thing. There's a program that's very useful for grafting flow charts and state machines. And it's called Mermaid. Does anybody know about Mermaid? Okay. Well, let me
Talking
share
about Mermaid Diagrams?
Yes.
Yeah.
Okay. I just saying it. Like I said, Cream, this might be the oldest thing in the world, but to me, I just ran across it.
Go ahead and share. It's great.
Yeah. Let's see if I can find it.
Is it anything like the old IBM template? You had like, here's a process box and I don't know what you call it. A diamond is like a decision block, and you'd have yes, no, coming out of two angles out of it.
Okay, so this is a copy of the live editor. Okay, so this is a state machine for one of my ideas. And so, I've always been weak on drawing state machines. It's just something that, I tend to get wrapped around the axle on. So this, it's here, you just essentially, you create a script and then it draws your diagram for you. And you can say, well, where would I use this? I mean, I got to make a script. How's this? This seems like what the heck? Well, with AI now, you can do, if you have a state machine, you can simply take the state machine and send that code to an AI, and it will generate a Mermaid. You can ask it to generate a Mermaid script for you. That's one way. Or if you're using AI to actually construct a state machine, then you can have it output this as a kind of a check to see, does this guy blowing smoke or what's going on? So it can also do, let me see if I can get to, all right, now I can't see what's going on, so you guys are going to have to, but like here's an example of a flow chart or a class. Okay. Let's see. I think this was a state machine. So there's a real simple state machine.
Crash.
So what I'm trying to get at is there's some different things you can do. It looks like you can even do an XY plot if you wanted to. So it's free. It's like I say, it's like a live editor. So you just stick your code in and it does whatever you want it to do. So I thought that if you didn't know about it, I thought this would be something that was cool. I'm going to go ahead and put the link in the chat and stop sharing. So anyway, another tool that you can think about, and you can think about using it in conjunction with, if you are out there coding with AI or what I think you said, Ray, you're using Co-Editor. Is that right?
Oh, me?
Yeah.
Copilot.
Copilot. I'm sorry. Yeah. So those are things you can do. And if I can find the chat window. Oh, here it is. So that's Mermaid. Oh, yeah, good point, Kareem. GitHub can show Mermaid diagrams and readmes. Is that a code window? Kareem.
What do you mean a code window?
Well, I mean, how does it show?
Like if you build a README file or any other markdown
so it's going to be in Markdown. So what Markdown does it use?
And you look at it on GitHub, it will actually transform the code for the diagram into a rendered diagram.
So what do you
diagram instead of the code?
What do you put in the README file? Do you put a code block with the script for the Mermaid?
Yeah, just put the 3 backticks
The what?
And you just put the 3 back ticks. To
Okay, that's
include
code block.
Yeah, code block, and I think you just label it Mermaid, and then put Mermaid code in there, and it just shows it as a chart.
Cool. That's clever. Thanks. I
Yeah.
hadn't tried that yet.
Yeah, that three back ticks thing, followed by some words like C# or
Yeah.
C or JavaScript or any of that, will clue into the markdown, and you'll get syntax highlighting on that too.
Yeah. I've done C++ with that, so but I didn't know you could do Mermaid. So anyway, something I ran into this week while I was doing some stuff.
Well, thanks, Doug.
Yeah.
Anyone else got something to present? Or question? Is that it for tonight?
Bye, guys.
Good night.
Good
See ya.
night.
Good night.
Night, guys.